Now, let us look at it from input side. Okay. Let us talk about, we have been, in a way we have been talking about profit maximization in the short run. Okay. Let me write it again. Profit is going to be, and this we can write it as P multiplied by Q, and Q is of course a function of K and L. And in short run, remember what did we say for illustration purpose, that we will keep the fixed cost will come from keeping the capital fixed, while we can vary the labor. So, we can say, let us say capital is fixed at K bar. So, it is going to be R K bar plus W L, and here also we will get K bar. Fine. Let me write it here, profit capital pi, not the small pi. The small pi is reserved for the maximized value, the maximized value of profit that can be achieved. Fine. So, this is capital pi, and what we can say, what we can do, we can rewrite it. If we draw, let us say on y axis we put y, and on x axis we put, or on y axis we put q, and on y axis, x axis we put L. Okay. Similarly, you can also think of this, that instead of profit maximization in the short run, we are talking about profit maximization in one variable, where only one input is required, and that input is L. You can take that it is some fixed number, does not matter. Okay. Fine. So, if we rewrite it, how can we write? We will take this on the left hand side, Q will be taken on the left hand side, and I can write it like pi plus, just rewriting, nothing fancy here. Fine. Is it clear? Now, with this, what we can get is iso profit line. Pi is equal to 0 will denote, because we are drawing in Q L L Q axis. L is on x axis, Q is on y axis. So, we are going to draw, remember like we had drawn iso cost line. How did we draw the iso cost line? What we did there, that R K plus W L is equal to a fixed number. Fine. Here also we can draw iso profit line, in the sense that profit on that line would be the same. And how can we get that? Let us say if we put pi is equal to 0, what we will get? We will get R K bar divided by P plus W P by L, and this is an equation of a line, and this line will give us profit is equal to 0. From here we get intercept. So, we can draw something like this. Let us say instead of taking pi is equal to 0, we take pi is equal to 1. What we will get? Q is equal to 1 plus R K bar divided by P plus W P by L. And what will happen? Just a parallel shift, because slope remains the same. What does change? From here, from this point, from this line to this line, only the intercept. So, there is a parallel shift, and shift is equal to 1 by P, and so similarly we get like this, and we can keep doing this. Is it clear? Also, of course, we are talking about production in short run. So, Q is equal to F of K bar L. You can also think of it that Q is equal to F of, let us say, let us use another function f of L, that it is production in one variable. So, that also we can draw, and if we allow for diminishing marginal productivity with respect to L, how would it look like? It would look like this. So, this is the maximum profit that can be achieved. This one is the maximum profit that we can achieve. And how much will be the production? From here we can get the production, here we can get the amount of L star, from here we get the amount of Q star. Is it clear? What is the idea? To get as much profit as possible. So, what is happening? Let us say if you keep on increasing L, let us say you start with 0, at L is equal to 0, you are not producing anything. So, your profit is equal to, it can't be, it may be negative because you already have some fixed cost, but if you start producing more, what happens? You are able to earn some revenue, and of course, you will be incurring some cost. As long as your revenue is more than the cost, you will earn a positive profit. So, as you move in this direction, profit, as we see from these lines, that in this case profit is increasing, but beyond this point what is happening? Profit starts decreasing. Why? Can you tell me?
Sir, because beyond this point the marginal productivity of labor
is so low that we will not be able to, adding labor would not add the output by much. So, the idea is to produce at this point, and that is that's where you want to be. Fine, is it clear? Okay. Now, we can do it using calculus also, but before that let us understand, let us try to do some comparative statics. What does it mean? That if we vary W, or if we vary L, or if we vary R, sorry, if we vary, what are the parameters here? The parameters are R K, R W and P. So, if vary one of these, what happens to the optimal amount of labor, and what happens to the optimal amount of output to maximize the profit? Can you tell me? Let us say if W increases, think about it, think for a minute and say if if W increases, what happens to the optimal amount of labor used for the production, and what happens to the output? Labor decreases and so is the Devesh, can you think?
So output we cannot tell.
You can tell both. Let me show you. Just fine. Let us say that this is the ISO profit line. Okay. This is where we are, correct. This is where we are, and here we are at Q, and of course, we have parallel ISO profit line. When W goes up, what happens to the ISO profit line? They become steeper. So, they will be like this. Of course, these are parallel. So, let us say now new point is here. Okay. So, L star dash, and L star dash is less than L star. L star corresponds to W, and this corresponds to W dash, and W dash is more than W, and this is the implication. Fine. Similarly, can you tell me what happens to when P increases? Both labor and optimal amount of output will increase. Why? Because let us see here, let us say earlier this is the, now what is happening? ISO profit lines are becoming even flatter. Look at this ISO profit line, what will happen? It will become like this if it is becoming flatter. So, of course, this company can make more profit by increasing, it will be producing at this point. So, earlier we were at this point. So, there is an increase in labor, and thus output will also increase. Is it clear? No?
Yes, sir.
Okay.